Can you hear me? Yeah, now. Thank you, Peter. Hello, everyone. Thank you for coming. Not many people here, but I hope that you enjoy the topic. So my name is Alba Rivas. I am a developer advocate at Salesforce. And here you have my contact details. If you have questions, you can ask me later, or you can contact me on Twitter, email. I always respond. Sometimes it takes me some time, but I always respond. So today, I'm going to give you, an introduction to Salesforce Functions. Do you know about this topic? Have you played with Salesforce Functions? I'm sure there are some experts here. So today is going to be an introduction, but there is some content going out very soon, which is about advanced Salesforce Functions, and I will share the resource at the end of the presentation. So I work for Salesforce. I need to include this slide, which just means that Salesforce is a publicly traded company, and you should make purchasing decisions based on the functionality that is generally available. So with that, let's start talking about functions. What is a function? So a function is a single-purpose, short-lived executable that you invoked on demand. So it's something that is going to start, is going to run, and it's going to end. And possibly, it's going to return you an outcome, a result, or it's going to generate a file, whatever, okay? So the two main characteristics of functions in general are, first of all, they are serverless, which means that you, as a developer, don't have to take care of the underlying infrastructure. And the second characteristic is that they are elastic, which means that the function will take more or less resources depending on the demand, okay? So there are some vendors that have implemented functions as a service since a few years ago. We have AWS Lambda, for instance. We have Google Cloud Platform Functions, also Azure. And since November last year, we made Salesforce Functions generally available. So I told you already something about functions in general. They are serverless and they scale elastically. But there are a few more characteristics that apply to the Salesforce platform and that may make Salesforce Functions a great choice for your use cases. So first of all, when you, I think it ran out of battery. OK, it doesn't matter. So first of all, Salesforce Functions run within the trust Salesforce boundary. This is, you have your organization, you have your Salesforce data in your organization, and it's true that they are running in a different infrastructure, in a new infrastructure that is designed especially for running elastically, but this infrastructure is connected to your Salesforce data in a trustful way. Your data never goes out from that trust boundary. And the third characteristic is that Salesforce Functions can be written in different languages. At the moment, we support JavaScript, TypeScript, and Java. But we are working on the support of Python, for instance. This is forward-looking. And they will allow you to expand your talent pool. Now, if you are a company, a development company, a Salesforce development company, so you might hire people who are like JavaScript developers, and they are going to be able to write functions very easily because it's supported, or Java developers, OK? OK, so when is it recommended to use a Salesforce Functions, right? Because they are not recommended like for everything. It's just for certain cases. So first of all, if you have a process, a business use case implemented in which you are reaching apex limits, or in which you want more compute capacity, you want the process to run faster, functions may be a solution for you. I will speak later about how transactions work with Salesforce Function, and that is something that you have to bear in mind when deciding to move your Apex code to functions. But definitely, if you have a use case like this, it's good to start thinking about moving, if it's a good choice to move that code to a Salesforce Functions. Because in a function, you are going to have like parallel computation, you are going to have more CPU, more memory, more heap size, etc. Okay? Second, if you want to use other languages of library or libraries, if you want to use an NPM library, for instance, that is something that you are going to be able to use from within a Salesforce function and that you cannot use from Apex straight away, right? And finally, there are some customers that have already some implementations of their business logic in other vendors that use functions or that have similar solutions to Salesforce Functions. So if you want to move that logic within Salesforce, within the Salesforce trust boundary, with that easiness that we have to work with Salesforce Data, thanks to the Functions SDK, and if you want to help those developers have the same developer experience that we have in Salesforce, I mean, when we develop Salesforce core functionality, then it's also a great opportunity to think about moving your use case to functions, right? So I wanted to tell you a bit about, not much, but just a bit of the open source technology that we are using to build that functions infrastructure. You know that now we are trying to do everything open source. Salesforce gave this turn some years ago, and you all know the benefits of using open source technologies. And one of the open source technologies that supports the implementation of functions is Kubernetes. Kubernetes is an open source orchestration engine for containerized applications, and that is what we use to run functions. We also use a technology called build packs. Build packs allow you to transform code written in different languages into an image that can run in that Kubernetes infrastructure. And we also use cloud events. Cloud events is not a technology, it is standard, but it's the way in which we define the events that we use to communicate your Salesforce or with the functions infrastructure. And how does a function look like, right? So for that, let's take a look at some code. So this is the code for functions recipes. Okay, functions recipes is a sample app that we have created. If you go to github.com/trailheadapps/functions recipes, you are going to find there some implementations of functions. We have a script to deploy them and so on. And you are going to learn how to code those Salesforce functions. And we are going to take a look at one of those functions. Is this function here, process large data function. As you can see, it is a JavaScript function. It's written in Node. And here, I can take a look at the code. Hopefully it's big enough, maybe too much, okay, of this function. So the use case for this function, it is, so there is a large JSON file. I'm going to open it so that you see it. That JSON file contains thousands of records of schools or high schools, universities that are all over the world, and they have information about the latitude and the longitude in which that school is. So the idea of the function is to get your position or a position that is provided, take a look at all those schools that are in the JSON file and determine which are the schools that are closest to you. So if you want to do this in Apex, you are going to reach limits. This is a use case in which we were pushing Apex limits. We were reaching Apex limits. But doing that through a function is straightforward. Okay. So here in the function, you will see that we have the way to define a function is through an asynchronous JavaScript function that always receives 3 parameters. So the first parameter is the event that launched the function. Functions are by nature asynchronous and stateless. So you invoke a function from Apex, from your Salesforce org, that is going to send an event that follows the cloud event format, and then that event is going to fire the function asynchronously. No? Well, later we will see that we have two options, but the function code itself is going to execute asynchronously. So in this event, we can find the information of the payload that was provided to the function. So if we want to pass a position, as I told you, here we get the event data, and that position comes here through a latitude and a longitude parameter. This is the payload that the function is expecting. Then we have a second parameter called context. Context is the connection to your Salesforce or data. And this is one of the most important benefits of functions, because through that context parameter, you are going to be able to access your OR information, you are going to be able to query data, you are going to be able to perform DML operations, and it's the glue that links back to your Salesforce data. And then we have the logger parameter, which is just an object that will allow you to log things in the console, in the log trains, okay? So here, what are we doing? So we take a look at the payload. We hope that a latitude and a longitude was provided. Then we go over all those school records that are stored in the JSON file, and we have a method to calculate the distance, and then we sort the results to find like the 5 schools that are closest to you, and finally, we return those records, okay? This is the function in JavaScript. But we can implement exactly the same in Java. If you take a look at functions recipes, you are going to find another implementation of this use case in Java. So this is the Java file, okay? And the code is very similar. It's a bit more verbose because it's Java, you know. But what we need to do is to implement an interface, Salesforce function, and then we need to override a method that, again, is going to receive as parameters the event with the payload, the context, which is the connection with my Salesforce data, and in this case, the logger that we use is a log4j instance. Again, we perform the calculation in Java, and we return the output. It's what I told you at the beginning, is it starts, executes, and ends. So that's how a function looks like, okay? So how do I work with Salesforce data in a function? I told you that there is an SDK, and we are going to take a look at some of the information that we can get in that SDK. The SDK is available through that context parameter, and we can access things such as the OR information. In the context.or parameter, for instance, here, we can access the OR ID, the OR API version, the base URL, the domain URL, etc. Okay? We can also access the user information because the function is invoked from Apex, and there is a user who invoked that function by firing that event, right? And we can access that information too. We can also query Salesforce data. Okay, we can use this is the context.or.data API variable to query data in Salesforce. And of course, we can execute DML operations. We could execute DML operations like individually, but there is something called the unit of work that is going to help you, first of all, control the transaction flow, and second, is going to save you API limits. So you have to think about the unit of work such as a table in which you are taking note of the operations that you want to perform in the database. I want to insert one account, I want to update one contact, and I want to relate those two records somehow. You are taking note of the operations, but you are not committing that work to the database till the end. When you finish registering all the operations that you want to perform, then you can do a commit, right? That way, if one of the operations fails, for instance, let's say that here the creation of the first account fails, the whole bunch of operations that you want to do are going to fail. So you have a way of controlling the transaction from the function. And also, we are not wasting API calls because we are just sending one API call. We are not sending one for creating the account and the other one for creating the contact. Okay? So this is very useful. And how is the developer experience to create functions? So one thing that the Salesforce Functions team wanted to do is to provide Salesforce developers a similar experience to the one that they have when they write Apex code or Lightning Web Components code. So, of course, what we are going to need is, first of all, the Salesforce CLI. So I don't know if you are aware of the CLI unification project that is taking place, but you are maybe familiar with the sfdx command. Now what Salesforce is doing is they have created a new executable called SF, and this new executable is going to include all the commands that you need to work with your Salesforce organization, but also the commands that you need to work with Heroku or with MuleSoft or other clouds, okay? They are trying to unify all the CLI commands. So as the Salesforce function commands are pretty new, they had been included in this new executable. They are not part of the sfdx executable because that one is going to be deprecated at some point, and they are part of the SF executable. We are going to see that it is very similar. You don't have to install anything special. This executable gets installed when you install the Salesforce CLI, like in the regular way, and you will have now the two executables available for some time, the sfdx one and the SF one, okay? And then what else do you need, or what else is recommended to have? The extensions for Visual Studio Code, because in the extensions for Visual Studio Code, you are going to have shortcuts and features within Visual Studio Code that are going to make much easier the way of working and developing functions, okay? So, enough of slides, I'm going to show you a demo, okay? First of all, we are going to run this function locally. I'm going to focus on the JavaScript function. So to run a function, let me open the command line. To run a function, the first thing that you would have to do if you want to do it with a CLI command would be run start function, okay? And this would start the function running locally in your local machine. But instead of doing that, I'm going to make use of one of the features that comes installed with the extensions for Visual Studio Code. And if I right-click on the function, here I'm going to have a shortcut that will allow me to start the function without having to write the command. So that's what I'm going to do. The function has started, okay? And now, once we have started the function, this is running locally in your machine. It doesn't need Docker, okay? Before, it was needed Docker to run the function locally, but that is not needed anymore. It's just using the resources of my laptop. And then, once you have started the function, you have to invoke it, right? We could do that also from a terminal, like running SF, I think it's run function. You have to specify like the place in which it's running, which now is like localhost, whatever, okay? And then you have to specify the payload, which in my case is going to be the latitude and the longitude. But again, I'm going to use one of the features that come with the Salesforce extensions because it's going to be much easier. So here, I have a sample payload that I want to use to invoke the function that I have running locally. And at the top of the file, you can see an invoke button that I can play to invoke the function. So let's do that. And this is what it has returned to me. Okay, it has calculated the schools that are closest to this location here. Okay, but I can do something even more interesting, which is debug the function. So here in the function, I have added a breakpoint, okay? And what I can do from this button here is to debug invoke. So this is going to use the Node.js debugger that comes with VS Code, and it's going to let me inspect the function. It has stopped here. I can take a look at the school data that I have in that JSON file, and I can debug the function if I am having any problems, okay? And again, it returns me the schools that are closer to me. So that is how you start and run and debug a function locally, right? But how do you deploy a function? So to deploy a function, you need to have an OR in which the function is activated. And one way in which you can have an OR with functions activated is by requesting a trial OR. I have been told that at the moment we are not giving more because we reached out the limit, a limit that we have internally, but this is going to be for some time only, and I know that we are also working in a freemium tier that is going to be easier to set up. So this will come, I don't know when, looking forward, but it will come at some point. But if you already have a trial OR, definitely you can deploy your function there. There were some courtesy licenses as well for customers, so reach out to your technical account manager and ask. So how do you deploy a Salesforce function? For that, I want to tell you a bit more about the infrastructure that is behind functions and about how you need to set up your CLI and your organization to be able to deploy a function. So let's say that I have my Salesforce OR, right? This is an OR that needs to have functions activated. So first of all, you need to connect your Salesforce OR to your functions account. You go to the setup menu, and there you connect it to your Salesforce functions account. Second, as with any other Salesforce development, we will need to connect the Salesforce CLI to the Salesforce organization so that we can work with that, right? And here I have decided to create a diagram for the Scratch or development model, but you can also use the traditional development model. So third, you will have to connect the Salesforce CLI to your functions account. This is a bit redundant, and I think it's going to disappear at some point, because if you are connected to your organization, you are already connected to your functions account. But again, this is safe harbor. And once you are connected to your Salesforce and to your functions account, you can start creating Scratch orgs. But what happens? That your Apex code and your Lightning Web Components code and your regular metadata code needs to be deployed to that Scratcher, but your functions go somewhere else. They go to a compute environment, okay? You can have more than one compute environment per org, because compute environments are associated to the combination of project name and organization. And the idea is that you have a use case per project. So if you have different use cases with different functions, you can create different projects and then have different compute environments associated with the same org. And of course, you can later create more Scratchers with more compute environments. And I wanted to explain you this because this is what we are going to do now. This time, I've recorded a video, okay, because it takes some time to deploy the function, and I've multiplied the speed so that we don't lose time. But I'm going to explain you, to walk you through the video. So, first of all, I told you, you have to connect to your functions account from your org, okay? Here I already connected, and this is the trial org that I requested in which functions is activated. Second, if you are going to use Scratch orgs, you need to activate a feature in your Scratcher, okay? You need to activate the functions feature. So what we can do now is to log in our functions space. So here what we are doing is connecting the Salesforce CLI to our functions account, and this is the step that I told you before that I think it will disappear with the time. We are connecting it, and it worked. So now we have both the Salesforce organization and the Salesforce CLI connected to our functions account. So what we need to do next is, well, I'm a developer, I want to create a Scratcher, and I want to deploy my function there. So to create the Scratcher, look like here I used the old sfdx command. You can use a new one, okay? There is a command that is sfenv create, I think, and you can indicate that you want to create a Scratcher. And I have been told that the new one is much better, but I was told that after I created this video, so use the new one, please. Okay. So now, what we are going to do is to create the compute environment, okay? This new infrastructure in which my functions are going to run. Okay, so now my compute environment has been created, and I have associated that compute environment with my Scratcher, because when I created the compute environment, I indicated that I wanted to associate it with my Scratcher. There is a way to list the compute environments and the orgs that you are using. This is equivalent to the sfdx force org list, but it's going to tell you also the compute environments. And you can see here that this is the compute environment, and they tell you which is the connected or alias, this one, okay? I have it connected to my org, and well, we can continue. So once we have the compute environment, we can deploy the functions. Here again, I'm using a command, but I could do that with one of the Salesforce, Visual Studio Code extensions features. I multiply this like by 10, okay? It takes a while to deploy. And that's it. That is how you deploy a function, okay? And then, if I go to the next slide, no. Okay, next slide, please. I'm going to give you a bit more detail about how you can find more information about functions. Because when you start playing with functions, at the beginning it happens that you deploy maybe the function and you have no idea of what happened because maybe you don't know how to take a look at the logs, etc. And one good news is that there are some S-objects in Salesforce that contain all that information. So there is a function reference S-object that you can query, and this S-object is going to contain the functions that are attached to my OR, even if there were functions attached to my OR in the past. There is another object called function connection that gives you information about the status of that connection with the compute environment. And there is another one which is function invocation request that allows you to monitor who and when invoked a Salesforce function in any of your environments. Also, you can find out some information about who has permissions to run functions and to deploy functions, etc., okay, in the permission set table. And finally, if you want to know more about the API limits that you are using for your Salesforce functions that, by the way, is different to the regular Salesforce API limit, is a different limit, okay? You can do it by running sfdx force limits API display. And I'm not sure if that command is available in the SF executable. I would need to check. So we've seen how a function looks like. We have run and debug a function locally. We have deployed a function to the compute environment that we have created. And now I want to show you how you can invoke that function, right? Which is the final purpose of all this. So functions are invoked from Apex. Of course, you can have a Lightning Web component from which you call that Apex method, or you can invoke Apex from Flow, like matching all the low-code capabilities to the function invocation. But the main entry point is Apex. And there are two ways in which you can invoke a Salesforce function. So one of the ways is to invoke the function asynchronously. This is the invocation that is going to happen in most of the use cases, right? Because normally, as a function is going to take a while, normally it's a compute-intensive process. It's good if you invoke the function, leave the function running, and then you check the result afterwards. So what you do is that there is a class in Apex called functions.function. You have to get a reference for the function specifying the function name. You have to specify the project and the function name. And then you call the invoke method. Remember that when we invoked the function locally, we had to pass a payload with our position, our latitude, and our longitude. Here it would be the same. We need to pass in a payload, which is the payload that my function is going to receive and use in the event parameter. As it is asynchronous, we want Apex to do something once the function finishes with the result. And that's why in the second parameter, we are going to pass a callback. Callback, it's a class that needs to implement the functions.function callback interface. And in that callback is where we are going to handle the response of the function. This is going to execute asynchronously. So this executes in one transaction. Then the function is going to execute outside of the Apex transaction, and you have to manage all the transactionality yourself with the unit of work and so on. And then the callback is going to execute in a different Apex transaction. And that is something to bear in mind when you think about moving your use case to a function, but it works because it works a bit different to how Apex code works. Indeed, you know that in Apex, if you have an unhandled exception or a governor limit, it rolls back automatically. That doesn't happen in the function code. So that is something that you will have to handle yourself. There is another way to invoke functions, which is synchronously, but this synchronous word only applies to the Apex code. What I mean with that is, in the Apex code, we are going to invoke the function, okay? And this line, the response line, is not going to be executed until the function finishes. But that doesn't mean that we are really synchronizing the transactions, okay? The function is still executed asynchronously because it receives an event, because its nature is to be asynchronous and stateless, and you will have to, again, control what you are doing in your function from the function code. A best practice that I have been told is that if you need to perform the ML operations, it's preferable to perform them in the callback in the Apex code once your function finishes, because you have more control with that. But of course, there will be cases in which you will have to use the unit of work and control all that from the function code. What else? I forgot to say, the asynchronous invocation has a timeout of 15 minutes, but the synchronous invocation only 2 minutes, okay? Which use cases may be suitable for a synchronous invocation? For instance, when you have a Lightning Web component that is invoking a function, and you want to wait for the result because you want to show something in the screen. And here I have another video in which I'm going to show to you how we invoke that Salesforce function, the one that we created before, okay? So we have a class in Apex. That class is invoking the function synchronously because we are going to call it from a Lightning Web component. It's the use case that I just told you. So what we do is that we instance the function, then we invoke the function with the invoke method, and then we can take a look at the status. If you see here, this is an Aura-enabled method because it's something that we are calling from a Lightning Web component. And in the Lightning Web component, what we are doing is to get your position from the browser. We are using the browser geolocation API. We are importing the Apex method, which is the way in which we can invoke that function. Okay? This is the code that gets your position, your latitude, and your longitude. And finally, we invoke that Apex method imperatively, right? Because we want to do it just one time. So I recorded this because I wanted to show you that, of course, we have deployed the function code to our compute environment, but I haven't deployed anything to my Scratcher. So what I would need to do now is to deploy this code to the Scratcher, okay? And now I'm going to stop the video here, and I'm going to show you the result of invoking the function. So this is the Scratcher that I deployed the code to, and to which I attached the computer environment. Here I have functions recipes deployed. And in functions recipes, we have a Lightning Web component. Okay, it logged out, I believe. Don't worry, we open it again. Okay. No problem. So there we have functions recipes deployed. It's opening. And we have that Lightning Web component, the Lightning Web component that we just saw the code of. Functions recipes. I'm running out of time. I'm going to try to be quick. Okay, implementation examples you can hear, and this is the code for that Lightning Web Component. I'm going to invoke the function, and this is invoking the function that is deployed in my computer environment. It's not a local invocation anymore because I have deployed the code. And here we have the result. The function is able to take a look at that JSON file, that large JSON file, and return the schools that are closest to me. So we are finishing. Now I don't find my presentation. But it just reminds me to share the resources. So the best place to take a look at Salesforce Functions resources and everything in regards to development are our developer centers. Okay, in the web page we have. In the web page, in the developer.salesforce.com web page, here in Discover, you have developer centers. And there are developer centers for everything. So if you go to the Functions developer centers, there you are going to find not only the documentation, but also the tools that you have to install, the related Trailhead modules, the related videos that we have published in our YouTube channel, the related blog posts. Okay, this is something that we update every month. So this is the best place in which you can take a look at resources to learn about Salesforce Functions. And also, I wanted to share this repo here. Okay, so at TDX, there was a session about advanced Salesforce Functions given by Andrew Fawcett and Julian Duque. And this is the code that they shared. I know that without the session, you don't have all the context, but they are going to publish a video in the developer channel very soon, like in a week or in 2 weeks, in which you will have the recording of what they talk about. And you have advanced patterns with Salesforce Functions that you can take a look at if you are curious and you want to start taking a look at those patterns. And with that, we have arrived to the end of the presentation. If you have questions, you can tell me now. Thank you. I don't know if I can stay 1 more minute, okay? Questions? Can a function call another function? Well, what you would have to do at the moment would be to return to Apex, and then from Apex, call the second function. Because the only way to invoke functions as of today is from Apex. But in the future, in the roadmap, it is to expose those functions like in a public endpoint. So in the future, you will be able to do it. Yes? That is something that we have in the roadmap. So in the roadmap, we will expose, again, looking forward, we will expose a public endpoint that will allow you to call your function not only from Apex, but from the outside. The license of functions. So the license is something that you buy per org, and then it has like a set of function, invocation, API calls, and also running time. It's something that you have to buy like per org. And there. I don't think you can associate a compute environment with several orgs today, but not sure if that will be available in the future. That is something that I should ask. I know that you can have an org with several compute environments, which is normally the use case, right? Because you have your production org, and then you want to call different functions from there. So I need to ask that. I will try to respond you somehow, like if they publish the video on YouTube, I will add a comment. Yeah, I'm not sure about that. I'm not sure. And that is probably something that you can discuss with your technical account manager when you buy functions, because the infrastructure, you know, same that you can have like Salesforce instances in different regions, probably it's the same for functions, but I don't know. Mhm. Any more questions? Oh, that's a really good question. There is a mock. So you can, there is a mock function behavior class that you can use in your test to simulate that the function went well or that the function failed, it returned an exception, whatever you want. In functions recipes, you have examples of how to use that test mock class. Mm-hmm. More questions? I don't see at the bottom, so I don't know if there are questions. Okay, so thank you so much.